Hello everyone. Today we'll be solving the problem number 206, reverse linked list, right? So I can just go through the question and understand the question via the example they have given, right? I'll just summarize the question so that it will be easier to understand. So what the question states here, we are given the head of the single linked list. You can clearly see here, we are given the head of the single linked list. Our main task is to reverse the linked list, meaning the last node becomes the head. This is important. Last node becomes the head and the next pointers of all the nodes are reversed, right? Last node becomes head and next pointers of all the nodes are reversed. Finally, we have to return the head of the reversed list. So keep this in mind. We have to return the head of the reversed list. So this is the question. You can clearly see here, head they have given 1, 2, 3, 4, 5, and finally the output should be we have to reverse the list, right? 5, 4, 3, 2, 1. We need to get the output here. So input here is head 1, 2 they have given, output 2, 1. Input head here it is an empty list. We have to get the output empty array in the form of empty array, right? So this is fine. So let's discuss the approach first and then we can discuss all the edge cases and finally write the code and discuss the complexity of the code that we have written. Initially, as usual, let's discuss the approach. So let's continue with the approach here. First thing we have to keep in mind here is we are going with the iterative two-pointer approach. Just keep in mind here we are going with iterative this one two-pointer approach. This is fine. So the first step here is previous and current. Will be making use of the 2 pointers, previous and current. This we have to keep in mind. And previous starts as null and current starts as head. Why previous starts from null starts as null and current starts as head here? Because previous starts as null because the new head of the reverse list should always point to the null. We know this. And current should current points to the head of the given list initially, right? So this is one thing. And let's go step by step. Next steps. So we have to save the next node here. We have to save the next node, right? Nothing but future. Let's consider the future here and reverse the pointer of the current node to point to preview. We are reversing the pointer of the current node to point to previous. And finally, we will move the previous and current one step ahead. So we will just move previous and current one step ahead. So that's what we will be doing here. After these steps, we have to continue until current becomes null. So we have to continue this until the current becomes null. So once the loop completes, right, then the previous will point to the new head. Once the loop completes, previous will point to the new head of the reversed list. Then it is said to be the list is said to be reversed, right? New head of the reversed list. So this is the approach that we will be going with. First, what we are doing, we are going with the iterative two-pointer approach. So we will be making use of previous and null. These are the 2 pointers we'll be making use of. And previous starts as null and current points to the head of the given list. Why? We have already discussed that one. And at each step, we are saving the next node, nothing but the future. Reverse the pointer of the current node to point to the previous. That's what we are doing here. Then finally, we are moving previous and current one step forward. We are continuing this process until the current becomes null. Finally, we know that the previous, once the loop completes, previous will point to the new head of the reverse list. So this is the approach that we will be going with. Now let's discuss all the edge cases and then let's write the code, right? So let me come here. Let's discuss all the edge cases here. The first edge case we'll be discussing here is empty list. Suppose we have the empty list head. Let me consider empty here. The output has to be empty here, right? So this is for the condition empty list. So the next edge case is nothing but single node. When we have the single node, right? So let me consider any number. Let me consider 1 here. The output will be 1 itself here. When we reverse, this is for the condition single node. Let's continue with the third edge case, nothing but 2 nodes. While I say 2 nodes, let me come here. Let me give here 1 comma 2. Let's consider simple example, simple edge case, right? So this will be 2 comma 1 here. So obviously when we reverse, this one will be 2 and it will be 1, right? 2 comma 1, right? So this is for the condition 2 nodes. And let's move with the final edge case or the fourth edge case. Nothing but the large input here. Large for the large input. Let me consider here input head, right? Head, this one 1 2 3. Let me give until suppose 5,000. Let's consider. So here reverse should be 5,000 4999 to until 1, right? So this is fine. This is for the condition large input. We have already written this one, right? I hope all the edge cases are clear here. First we discussed about the empty list. Second is for the single node. Third is for the 2 nodes. And fourth one is for the large input. This is fine. These are the 4 edge cases that we need to keep in mind. Next, let's write the code and I'll just explain the code while writing the code itself. And finally, let's discuss the complexity of the code that we have written. So let's start writing the code. First, let's initialize 2 pointers. We know that previous points to null and current points to head, right? So I'll just give here previous current within the array. Let's consider this points to previous points to null and current points to head. This is fine. Next step is we have to traverse the linked list. Suppose we have let's consider the condition while current not equal to null. So we should have some value, right? Then we will proceed with the further steps. So as we had discussed in the approach, let's save the next node future to avoid losing it, right? So I'll just consider one variable future here. We have already discussed this one, right? Let's save the next node, nothing but the future here, current dot next, and reverse the pointer of the, we have to reverse the pointer of the current node. This is simple. This is nothing but current dot next. Yeah, this points to the prev. This one has to be C here. Now this is fine. Now we have to move the previous one step forward. Also we have to move the current one step forward, right? These 2 steps we need to do. So previous, this one, current, and current. When we move current one step forward to the save future, right? Here this has to be future. Sorry, I got confused here. So this is fine. Then finally we have to return the new head of the reversed list. So just return the head here. Sorry, not head. Previous points to the this one, right? New head of the reversed list. This we have discussed during the approach, right? Let me format this one. Let me code now. So you can clearly see here the sample test cases are getting passed, right? So let me hit the submit button now. So all the test cases are getting passed here. So the code works absolutely correct. Let's quickly discuss the time complexity and the space complexity of the code that we have written. So the approach that we went with here is iterative two-pointer approach. So the time complexity here would be big O of n. Overall time complexity would be big O of n. Why? We are traversing each node exactly once here. We are traversing each node exactly once. And what about the space complexity here? The space complexity here would be big O of 1. Why the space complexity here would be big O of 1? Because we are not making use of any extra space, right? We are making use of only 2 pointers here, previous and current, right? You can clearly see here. So the overall space complexity would be big O of 1. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.